our Today with our contemplate and then calculate problem, we're going to be focusing on fractions. I know a lot of you are uncomfortable with fractions, so hopefully our little study of this problem and their structure today will help it make you a little bit more comfortable with the fractions. I'm going to put the problem up on the board. I don't want you to write down any calculations right now, but if you need to write down any of your observations, you can do that. It's try to keep them on your head sometimes. Remember, any observation counts, whether it's just, well, they used all twos. It doesn't matter what you might notice. It can be something very broad or something very small. So take a few minutes to look at it just by yourself for a minute. Well, what you notice. When you think you've noticed all that you could notice about our little problem there, talk to your partner or the rest of your group and see what things that they might have noticed that you didn't, or things that you saw that they didn't see.
Jessica, go ahead and take the problem down. So no one's tempted to do any more calculation on it.
Yeah, what's the first one, Victor? Well, the first one. 4 and 2/3 and 3 and
Okay, I think we've got all of our observations out, so let's talk about them in our whole class. Make sure everyone in our class knows things we observe. So in our first group, what's the first thing you noticed about this problem?
We noticed that both of the terms we're multiplying are mixed numbers.
Okay, we have mixed numbers here. Can't write that. Does anyone need clarification on what a mixed number is? You can just throw that out there, make sure we all understand what that means. Okay. Josh, can you tell me what a mixed number is?
Mixed number is basically a notational way of writing a whole number with fractions. Basically, the whole number plus the fraction that we just write as a mixed number. Or
Awesome. Great explanation. Corey, what does your group notice?
It's multiplication.
Multiplication, that's important. Josh, what does your group notice?
Josh is always in the
I
hot
know,
seat.
he's like, he's
He's the one looking at the person
call on
in front.
David.
Let's call on someone else.
David, what does your group notice?
notice the first one is bigger than the second.
Okay. Should have a lot more observations. Now that your group has shared, if you have something else that you noticed about the problem, you can just mention it. Corey?
We don't have a common denominator, but
Okay.
we can easily make it 12.
Okay. So what could the common denominator be?
12.
But I'm going to throw an error to say that it could be 12. If you need to think about it that way. What else do we notice about the problem, the numbers in the problem? Rachel?
We noticed that the coefficient numbers in each of them are the same as the denominators in the opposite one.
Okay. That's a very good observation. What do you mean by coefficient numbers?
So the 4 and the 3 that are like the whole numbers and our
Okay.
mixed numbers are the same as the third and fourth denominators in
Okay,
the opposite.
that makes sense. So I'm going to say that the whole number is equal to the denominator of the other. Just to abbreviate that. Any other observations that we get from looking at this problem? Anything else?
I mean, the only thought I was going to say, so I immediately thought that we have to make it to a proper fraction. So is that realistic?
if you think that improper fractions might be helpful in solving it, so we could think about that. That mixed numbers, we could say that we could put them in improper fractions. That's what we're sort of trained to do.
Yeah.
But again, if you don't have to, so I'm gonna put this here, because we also don't know if we're really gonna need the common denominator thing, but it's something that we're gonna think about when we look at fractions. I think we have a good base of observations here. So now we go to this side. So now I want you to take a minute to yourself to think about how we can use what was noticed to find the answer to this problem without doing the standard calculation that you have to do. You might end up doing a little bit of addition or multiplication somewhere, but without skipping some of the harder things. Then you can use your pens and papers now if you need to. Work on your own just for a minute, and you can talk with your partner when you both seem like you're finished.
Jessica, do you want people talking in their groups?
Yeah, so you can go ahead and start talking in your groups if you need to. You guys have worked on it. This one might be a little bit trickier. That's something that we've done before. You might want to think about what a mixed number actually means. See if you can do something like that.
Can I do a timeout? We often don't get insight into this phase of it, but I just overheard Jessica, you say something. You might want to think about what a mixed number means or
What
something.
a mixed number really means.
Yeah.
Because I had a question over here about how I'm trying to think about a different way to do it than the regular way. So that's why I had Josh earlier mention that what exactly a mixed number means.
Right.
So you might want to think about that because it's kind of a key part of
So
our.
the group was at a point where they kind of weren't progressing.
Right.
And you offered something that could perhaps stimulate that. Awesome. So I think that's a nice, we often don't know what to do when we reach that struggle point. So that was nice.
Did you explain what you did to your friends? Did they not understand? Okay.
I was really proud that I thought of it. I have to bring to this tonight.
And I think we have a lot of people that seem that we either are just stuck as to where we should go next, or we have the other half people that have found our shortcut. So let's see if we can elaborate on this a little bit more. I want to first talk about why we might want a shortcut with this problem. I noticed a lot of you did what right off the bat? Improper fractions, right? What happened when you got to your improper fraction squared? What made it difficult to do? 14 times 13 on the top, right? That made it a little bit difficult. We don't usually know what that is. You know 12 times 12, but that's sort of the cutoff there. We don't know what to do after that. So while we have this standard thing in our head of how to multiply mixed numbers, it didn't really work very well for us this time. So that's why we need something else. So what is the something else that some of us came up with? First person I saw that got it was Carla. Would you like to share yours?
So I did the factoring method where I did 4 plus 2/3 and 3 plus 1/4. 4 and 2/3 is like 2 because I thought that'd be really difficult, and then I realized that the firsts are obviously whole numbers, so that's not that difficult. And then 4 times 1/4 will take cancel, so you would get.
Okay, hold on, stop just for a second. So what did you do first once you got here? You just
I foiled. So I
foiled
did
it.
the
Okay,
first.
that's what I was looking for. So you did the first one. So we had 4 times 3, and then what did we come up with?
And then you do 4 times 1/4, this is the numerator, and then denominator. 4 and 1/4 gives you 1.
Yeah,
So that was, and then 2/3 and 3 would give you 2 because the numerator, or 3 in denominator. And then the hardest part was 2/3 times 1/4, but I took a 2 out of 1, like I canceled the 2 on the top of 2/3 and made that a 2 on the bottom since 4 is 2 times 2.
And got 1/6.
So then I left it as a mixed number, so the problem was a mixed number.
Very good. 15 and 1/6. Take a minute to look at what this solution method was, because I know a lot of us weren't quite getting there. Think about what Carla did and what observations she used to come to this conclusion. Haley, can you talk about what of these observations that Carla had to use to get to this solution method?
She used the fact that a mixed number is like an integer, I guess, plus a fraction.
Perfect. One thing that she used. What other observation did she use, Nick?
She used that, once you had it all done, so, I'm confused. I like watched what she did, and I was trying to do it while she did it, and I got so confused, I got lost.
All right, what part of it doesn't make sense to you?
When she broke apart the 4 and the 2/3,
Uh-huh.
I started, oh, that's what she did.
What's your aha moment? Can you share it with the rest of the class?
Yeah, she did like 4 times 3, so she did like the foiling.
Yes, so we just folded it. It's very similar to
I
what
broke
we
it
have
apart.
done before. We don't often think about that you can break it apart, but that's really what a mixed number means. And then we're used to this method when we have 2 things added, then multiply those together, we can do the foiling method. Does anyone know what other observation that she had to pull from light upon this? One more that's up there. If you brought it up. Do you know which one I'm talking about, Carla?
The whole number is the denominator.
Right.
The whole number is the same as the denominator.
The whole number is the same as the denominator in the other one. So when you see this, you might stop and think, oh, look, there's something that might cancel out there, and how can I get to there? So you might not notice this at first, but what might happen is some of the other observations that you make might be able to come into play later. That's why we want to get so many things just out whenever we look at the problem, because there might just be something random that comes out that makes you realize this method. Sam, could you, just to make sure everyone's clear, reiterate what Carla has done here with this problem?
So she just rewrote the mixed number as 4 plus 2/3 and then 3 plus 1/4 and then multiplied them together and foiled.
Okay. And then why was that a whole lot easier, Corey, to do it that way?
Because otherwise you were trying to multiply by large numbers and they weren't going evenly into each other.
The only complicated thing that we had to do here was the 2/3 times the 1/4. Carla made that easier by reducing by 2s, but even if she didn't do that, you would just end up with 2/12, and those aren't hard things to think about besides the 13 times 14 is kind of a complicated thing to do. Did anyone come up with any other solution methods besides this one and besides our standard algorithm that they would like to share? Does anyone think of anything now after we've seen this one here? Okay, to close out what we've talked about, I want you to take a minute to reflect on what we have noticed today about multiplication and fractions and mixed numbers and everything. I want you to write a sentence that sort of details what your thought process was on this. You might say something like, because I stopped to contemplate first, I was able to notice blank, which helped me blank. Something like that. Take a minute to write down your thoughts about why this contemplating this problem made it a lot easier in the end to do. When you finish with your sentence, you put your pencil down so I know you're finished. Normally I would ask you to share with your partner now, but you worked with your partner a lot today, and we just have a small class, so I think we'll just share a few of these, one from each group. So David, if you want to share what your reflection sentence is for us.
When you separate a mixed number into the whole number and the fraction part, and when you go to multiply these sums, the multiplication can be a lot easier than if you had changed the mixed numbers into improper fractions and multiplied that way.
Very good explanation of what we did today. Sam, share your sentence for us.
Basically just, thinking about the structure of the problem made me think more about what mixed numbers really are, because when I first see a problem like that, I just want to go ahead and jump into improper fractions.
We've been so trained to do that, and that's what we need to do. But this one, once you realize that, it was a lot easier to solve it. You almost don't even have to write out all your steps. You can almost do that from your head. And last one, Rachel, you want to share your reflection statement?
Yeah, mine's very similar to both of them. I noticed that I was working with mixed numbers, and this helped me to break it apart by using what a mixed number is to be able to formulate.
Thank you.
Thanks, Jess. Okay, so